Hello, this is tutorial number 2B, where we're going to model a 3-span continuous beam subjected to a uniformly distributed load using SAP2000 model 22, version 22. So let's go ahead and get started. Okay, this is SAP2000, and this is the student version that you guys are able to install on your own computers. And the first thing that you get when you launch it is a little warning message or informational message that tells you that it is a limited version. You can only have models with 100 point objects or 100 analysis joints for linear stuff or 30 analysis joints for nonlinear stuff. That's not going to be a huge limitation for the stuff we do in this class until we get later into the semester. Let's go ahead and close that window, and I'm going to maximize this. And one of the first things that we're going to do is go ahead and create a new model. So as a reminder, here's the assignment for this particular tutorial. We have a 3-span continuous beam that's made up of a W36 by 231. It's subjected to a uniformly distributed load of 1,450 pounds per linear foot. So step number 1 is going to be go ahead and select a new model. So that's this button up here on the upper toolbar. Note that we have 2 toolbars and a set of menus. So the interface for SAP2000 is a little bit cleaner than it is for visual analysis, but maybe it looks a little bit more dated too, I guess. You might be used to the ribbon format from Microsoft Office applications and from using Revit. Anyways, from the upper toolbar, we can select the new model button, or we could go into the file menu and select new model from there. That brings up a window. Here it is, and it lets us select our units. So I'm going to work in kip feet units at the beginning, and we have a number of different templates that we could use. Some of these are really helpful, but to get things going from a rudimentary standpoint, I'm going to use the grid only model. So I'm going to set up the grid in this SAP model the same way that we did with the visual analysis model. So in order to get the same setup, I need 42 divisions in the X direction. It doesn't matter how many we have in the Y direction. I'll put in 1. I'm going to use 10 in the Z direction. My units are feet, so I can type in 5 feet here for the grid spacing in the X direction. In the Y direction, it doesn't matter, so I'll type in 5 feet. And then if we want to, we can type in 60 inches for the Z direction, and that automatically changes to feet. If we want the first grid line to be at an X location of -5, and we want the first grid line to be in a Z location, rather, of -25. So in defining this grid, bear in mind that SAP2000 uses the Z-axis as the vertical axis by default. You can change that, much like you can change in visual analysis. So the visual analysis uses something other than the Y-axis, but I found it to be more convenient to just get used to it. And odds are, when you guys are practicing engineers, you probably won't use more than one analysis package anyways. Maybe you will, but probably not. So you'll probably just get used to the defaults, or maybe your office will have a standard operating procedure or something like that. All right, another thing, if you forget which units you're working in, down here in the lower right-hand corner of the screen, it displays the units, and in a lot of cases, you can actually change the units on the fly. All right, so hit OK, and we're given this window here. Excuse me. So we don't need both of these views. This model is fairly simple. It's just a set of linear elements, a beam. So I'm going to close the 3D model window. We can use that sometimes, but we're not going to do that today. Our model is defined in the XZ plane, but we're currently showing the XY plane at Z equals 20 feet. I want to show the XZ plane instead, so I'll select this button on the toolbar, the upper toolbar, the XZ, and that gives me the XZ plane. And now I can use the mouse wheel to zoom in and zoom out a little bit to fully utilize the window that we have. Okay, let's go back over here to our step-by-step. All right, I'm going to go ahead and set the analysis options at this point. We're doing a 2D frame analysis, so I go to Analyze, Set Analysis Options, and I could deselect these degrees of freedom manually, or it's easier just to hit this button in the middle that says Plane Frame in the XZ plane. And then that gives us UX, UZ, and RY as our degrees of freedom for displacements. So the U means translation, and the R means rotation. So UX and UZ mean displacement X and displacement Z, and the RY means a rotation about the Y-axis. I'll go ahead and hit OK at this point, and then we'll go over here. And step 2A is where we start actually drawing our frame elements. So we can actually select the Draw Cable Element tool. All right, there it is, Draw Frame Cable tool from the left toolbar, the vertical toolbar. I'm going to move this little window up and out of the way. And we click to start dragging our member, and it gives us the length right there as a pop-up window. We let up to, or click again to define the end of the first member. Then we go ahead to a length of 75 feet. Click again, and we go to a length of 60 feet. And click again, and then we right click in order to stop drawing, and then we hit escape to exit that mode entirely. So there's a little bit of a difference in behavior from SAP-22 in this case. It gave us the length as a pop-up thing. If you're using SAP version 19 in the computer labs, then you don't get that length, but the basic procedure is the same. You drag to create objects. All right, now the nodes aren't showing here, but they were created when we generated the line objects, the member objects. If we go up here on the toolbar to this, the upper toolbar to this button that looks like a checkbox, that's really going to let us set our display options. So if I click on that, it lets us display or hide different things. So this is like filters in visual analysis. By default, usually, the joints are set as invisible. We don't often need to know where the joints are once we get used to modeling, but here at the beginning, I'd like to make sure that they're in the right spot. So I deselect the invisible checkbox, and then I hit apply and close that window out. And you can see these little nodes have popped up. They're not very large, but they are there. I'm sure there's a way we could adjust the node size, but I won't take up your time with that right now. Okay, now by default, the members weren't drawn as W36 by 231s. We need to define them as W36 by 231s, and that process takes a couple of steps. The first step is to go to the Define menu, then select Section Properties, and then select Frame Sections. Okay, look, there's a lot of different things here. We have tendons, cables, areas, solids, a lot of different things in here, but right now we're just working with frame sections. So we select that. That brings up this window, which indicates that the members were automatically defined using an FSEC1 property. That's shorthand for frame section number 1. And it probably just has some generic section properties in there, like moment of inertia equals 1, area equals 1, etc., etc. If we go over here, we can import a property. We're going to work with steel, and I want an I section or a wide flange section, so I click that box. Now, at this point, you need to import a properties data file. So the .pro file stands for properties. This is usually in the C Windows Program Files directory, Computers and Structures. CSI is the company that makes SAP2000. And then my computer, when I installed it, created a directory called SAP2000-22 student. So that's where it goes by default. You can select AISC 15. That's the 15th edition of the AISC manual. If you're using SAP-22, if you're using SAP version 19 in the computer labs, then AISC 15 isn't available, but 14 is, and there aren't too many differences in the section properties. So I'll select that, hit OK. Then it brings up this window and lets me select which of the cross sections I want to import into the model. So this has some typical Windows functionality. You can hold down the Shift key and select a block. You can hold down the Control key and select a few at a time. I only need one for this model, so I'll select the W36 by 231 and then hit OK. That shows us the section properties are going to be imported. We could also define materials here and do some other things that we'll discuss later on. At this point, let's just hit OK and back out to the main window. Now I still need to select those members and change the properties, so I'll drag a window, select all three of the members, and then go up here to Assign, Frame, Frame Sections, and then in this window select the W36 by 231, hit Apply, and then hit OK. And SAP gives us the 36231 designation, so we know that we have those assigned properly. If you're not sure that the sections were properly assigned, then you can go to the Set Display Options dialog again up here in the upper toolbar. And in this case, you can make sure that sections are displayed. So there's a lot of things we can do with this dialog box. So the sections are displayed there. You can also set labels for the joints and show those joint labels. There they are. We can also set labels for the members. So now the member labels pop up. SAP, though, isn't that smart when it comes to this. It actually wrote the section labels and the section properties over each other. So let's see. There we go. Okay. All right. So then the next step in the process then is to we need to set joint restraints. So I'm going to select the nodes. I can click on them if I want to, or I can window them. I'm going to do the first one, node A. I'm going to click on that, and I go to Assign, Joint, and then Restraints. So in this case, I want it to be a pinned joint. The translation 2 direction, translation 1, 2, and 3 corresponds to the X, Y, and Z axes. Why doesn't it just say X, Y, and Z? Well, each node has its own local coordinate system, and rather than calling it the X, Y, and Z for local and the X, Y, and Z for the global, they call it the 1, 2, and 3 directions for local. They call it the X, Y, and Z for global. So by default, 1 corresponds to the X direction, 2 corresponds to the Y direction, and 3 corresponds to the Z direction. You can change that, but we don't need to worry about that for now. We'll deal with that later in the semester in a future tutorial. So anyways, with 2 corresponding to the Y direction and with degrees of freedom in the Y direction being deactivated, it really doesn't make any difference to us. We can leave that checked. We can uncheck it, whatever you want. Hit Apply, and it shows us the reaction over here. It kind of gives us a little triangle. So then I'm going to go ahead and select the remaining nodes. I'll just window over them. And then in this case, I want a horizontal roller. So I select that, which restrains just translation in the 3 direction or in the Z direction. I hit Apply again. And now you see those rollers that are there. So let me hit OK. I'm going to go ahead and select the 3D view for a second. And that shows us the beam. Okay. Now, if we want to, this is not in the PDF, so a little value added for you. We can actually show the cross-section of the beam if we change our view type. So I did that a little fast. If we go to Set Display Options and then change tabs from Object Options to General Options, we can look at the Extrude view. And if we do that, then what we get is the actual cross-section of the beam, where we can look at the flanges and the web, and we can see that that beam is oriented correctly. Okay, so that's kind of cool. The graphics are pretty nice in here, and it does fairly well. It's not as good as Revit with rendering and stuff, but it's certainly fine. So let me get back to the view that we had before. I'll go back to the standard view type, hit OK. And then go back to my XZ view here. Zoom in just a little bit. There we go. Good to go. Okay, the next step then, step 4, is to define the loads. And this is a several step process in SAP. It's complicated because it's very robust. First thing we need to do is define the load patterns. So in SAP, we have load patterns, load cases, load combinations, and then there are some moving load properties as well. So the load patterns are basically the source loads that are applied to a structure, like the snow resting on the roof, or the rainwater on the roof, or the wind that's actually blowing. Load cases tells SAP what kind of analysis to perform for each one of the load patterns, or combinations, or groups of patterns. And then the load combinations is like the combinations that you have in ASCE7, where you're going to take 1.2 times the dead load plus 1.6 times the live load. It's a lot more complicated than that. There are a lot of different options in SAP, but as a starting point, let's use that as our definition. So first, we need to define the load patterns to tell it what loads are on the structure. Then we need to define the load cases to tell SAP what kind of analysis to perform with the load patterns. So I click on load patterns. That brings up this dialog box, and by default, SAP has defined a dead load pattern for us. That's fine. The uniform load that we're going to be applying is a dead load, so we'll just leave that alone. But note that there's a self-weight multiplier in here like there was in visual analysis. I'm going to change that self-weight multiplier to 0 by changing that value in the header box there. And then I hit modify load pattern to change the value to 0 down here in the list box. Then I hit OK, and we're done defining the load patterns. Now I need to actually apply the load. So I'm going to select all the members, dragging from left to right. And now I go to the Assign menu item. Don't go to Frame. This is not intuitive. You go to Frame Loads. And then down here, we could define a gravity load if we wanted. But instead, I'm going to use the Distributed Load option, which I've had better luck with. So in this case, I want to apply dead load. So load pattern is dead. I'm going to apply it in the global coordinate system as opposed to the coordinate system associated with each of the members. And I'm going to apply it in the gravity direction. Now we have the option of selecting X, Y, and Z directions, or projected directions. I'm going to say gravity, and then I'm just going to put in a value of 1.45 kips per foot. Now, since it's positive, that works fine as long as the direction is gravity, because the gravity direction is in the negative Z direction. If we put in the load direction as the Z direction, then we would have to use a negative sign on 1.45 in order to make that work. All right, so with all of that, I can go ahead and hit apply and then hit OK, and we get that for our window. All right, so at this point, we should be good to go to run our analysis. So I'll go ahead and hit this run analysis button. It looks like a play button on the upper toolbar. And whoops, I forgot a step. Pardon me, I forgot to delete the modal load case. Let's go to define load cases. And by default, SAP generates a dead load case and a modal load case. And the modal load case gives us the natural frequencies of vibration, natural periods of vibration, and the mode shapes. And I don't want that right now. Usually it's okay to leave it in place, but sometimes it generates error messages or warning messages. So I'm going to go ahead and delete it just to have a cleaner example. So delete that from the load cases and then hit OK. Now I'll run the model, run the analysis. I'm going to hit the run button, and it's going to make me save the file. So I tend to save things on an actual physical drive. I'll go ahead and call this tutorial 1B demo to distinguish from the version that I created a few minutes ago when I was working through it the first time. And I usually save these on a physical drive, not a cloud drive. I've had problems in the past with SAP, and I'm not positive that the problem was using a cloud drive, but I think it might have been. So I'm reluctant to save it to a drive that is linked to Dropbox or OneDrive or something like that. I just save it to the C drive, and that works out pretty well for me. All right, so we've conducted our analysis. This is the deformed shape of the beam, and one of the first things that we should do is to take a look at the log file for the analysis to make sure that there aren't any error messages or warning messages. So we can go to the Analyze menu, show the last run details, and then this is basically a text file that gives us a summary of the type of analysis that was performed, and I'm looking right now to see if there are any errors or warnings, and I don't see any. Okay, so When you go to the directory where you store the file or save the file and look at it now after running the analysis, you can see that SAP for that particular model has about 20 different files that it says actually 55 different items. That seems a bit excessive. No, 18 items selected. So you want to be careful where you save this. If you save the file on your desktop, for instance, your desktop is going to be full of these scratch files and working files when you get done with the analysis. All right, so here's the deflected shape. You can do a lot of different things with that. So here's the button that allows us to do the deflected shape. Let's close that out. Let's go ahead and plot shear force and bending moment diagrams. So we can go to display, show forces, stresses, and then go down here to frames, cables, or tendons. That's the menu pick. It's also available up here in the toolbar, show forces and stresses. So I'll click it there. And the moment about the 3-3 axis is the primary moment, and I'm going to fill in that diagram. So I hit apply, and then I hit OK to close out that window. And look at our bending moment diagram. Looks great. It's pretty blue and red, but it's upside down. At least it's upside down if you took your analysis class in the United States. So we in the United States draw our bending moment diagrams for the compression side, but the rest of the world does it for the tension side. So SAP gives us the option of reversing that. If you go to options, moment diagrams on tension side, and deselect that button, then SAP will flip the moment diagram over for you. So it gives you that as your bending moment diagram. Okay, we can also draw the shear force diagram. We go shear 2-2, and that gives us that as our shear force diagram. Now the diagrams for shear in SAP are basically backwards from what we're used to because of the way the moment diagrams are drawn. So you have to invert that manually. You can also annotate these values if you want to. If you do that, you end up with a diagram that looks like that for shear, or a diagram that looks like that for moment. So you can see these values on here. You can also use your mouse and scroll along here and pick values a moment off at any arbitrary point. If you want more refined results, you right-click on one of these members and it brings up the diagrams for frame objects window. And in here you can show the maximum value. So we have deflection down here at the bottom. You have moment diagram, shear force diagram, and the distributed load diagram. We can change this from kip and feet units to kip and inch in units, and then we can see the results that we want. Okay, so close that out. That's about it for this one. Let's see. Let me go back over here. Let's see, what else do we have in our tutorial? Oh, reaction forces. Let me show you reaction forces. So if you go up to the top, you can also show forces and stresses for joints. And that lets us display either arrows or tabulated. So we can do arrows first. So there's our reaction forces drawn as arrows, or we could also show them as tabulated values. And so that gives us force in the 3 direction is equal to 109, force in the 3 direction is equal to 32.36, etc. Okay, let's see. I do believe that's it. Yep. I think we got it all. So there's a summary of our results for SAP2000. If you want to, you can also export data. This is a pretty handy feature in SAP. It's very well done. So if we go to display and then show tables, it allows us to export this data. So we can export just about everything that SAP has associated with this file if we wanted to. I want to go joint displacements, joint reactions. For the elements, I want the frame output. For the load pattern, I want to make sure we're doing dead load pattern. Then I hit OK. It brings up this, which is a poor man's version of Excel. Everybody wants to use Excel. There's nobody that doesn't want to use Excel. So we can export either the current table, or we can export all the tables to Excel. And when you do that, it launches a version of Excel and populates the workbook. Where is it? There it is. And populates the workbook with the data. So now you can do your manipulation here. But note that we have several different tabs with different data that I selected. Manipulating that, understanding that, interpreting that is a topic for another day. No, I don't want to save that. Go away. Thank you. Here we'll go done. All right, so we're good to go with that. I'll save that. Let's see. All right, so we created this model pretty much manually. I'm going to go ahead and select a new model again. And I'm going to use the template a little bit more strategically in this case. I still want kip and feet units, but in this case, I'm going to use the beam template. So if we select that, we know that we have a 3-span beam. The span lengths aren't all equal, but most of them, 2 out of 3 anyways, have a span length of 60 feet. So I'm going to go ahead and type in 60 there to act as a seed value for using the custom grid. So then I edit this and it gives me the ordinates. What it's doing is placing the origin of this model at the center of the girder, center of the beam. I find it easier to use with spacings. So we go in here and we can see A, B, C. I want B span length to be, 75 feet, not 875 feet. Then I can go back here to ordinates and that works out fine there. So I can type in a 0 there. So you go back to spacings. So that's 30, 75. That should be, 60, 75, and 60. This should be A, B, C, D. And now we can hit OK. We can import our beam section properties like we did before. So I need to tell it AISC15.property. Go down here and find the 36231. Hit OK, hit OK, hit OK, and then generate the model, including the restraints. And that gives us our model shown like that. It did put the origin in a goofy location, though. I don't feel like redoing it, so I'm going to leave that alone and let you guys tinker with it. So at this point, we still need to set our analysis options, right? We still need to define our loads and other things, but sometimes if you're doing a quick beam model, it's quicker to get the geometry of the model imported like that. Okay, I think that's it for this one. So I'll go ahead and close this out, and we'll see you again soon.